Hello coders, Synthetic Programming here with another video for you guys today, and today we are going to be making a chemistry equation balancer in Python. So for anyone here who's done chemistry before, you've heard of stoichiometry, which pretty much just means you have a chemical equation, you've got your reactants on the left, and on the right you have your products. This is like a very simplified version, but you have to find the correct ratios, the correct molar ratios to balance the chemical equation. If you've ever taken a chemistry class, you've probably done tons of homework on this. So I'm going to be making today with you guys a chemistry equation balancer that does it automatically for you. You put in the chemical equation unbalanced and it balances it for you through random number generation. So after this project is done, I'm actually going to be sending it to two of my favorite chemistry channels. Cody's Lab is one of them. He's not exactly a chemistry channel, but does a lot of chemistry on his channel. And I'm also going to be sending it to Nile Red, another one of my favorite YouTubers. So, okay, let's get started. This is going to be a long one, guys, so get ready. The first thing we're going to do is we're going to create a new file called equation. And make sure it's lowercase. So equation is going to be where we write our equation class. And for this class, we're going to need a couple imports. So the first thing we're going to do is we're going to say from random import randint, because we're going to need those random numbers. From math import GCD, greatest common denominator. And then the last thing we're going to need is from functools import reduce. These are the three imports we are going to need for this project today, guys. And the next thing we're going to do is we're going to create a class. Now, a class in Python, if you know Python relatively well, is like an object. So for example, a list in Python is a class and a string is a class. We're going to be making our own class for a chemistry equation. So we're going to say class equation, and that's that first line. Now here we're going to write a little note and say a chemistry equation, and then we are going to continue writing our class. So the first thing when you create a new class is you need an initializing function. So when you make a new list, this function runs and creates that list that you're going to put stuff in. So the first thing we're going to do now is write def underscore underscore init. That makes the function. And we're not only going to use self as a parameter, we are going to use equation, because we're going to be inputting an equation into this function. So we're going to say this initializes the chemistry equation. And then down here we're going to say that the type of equation, and if you guys remember, this is going to be a string, but if you guys remember, the stuff in green doesn't actually do anything, it's just comments so you can remember what you've been doing. When this stuff runs, it doesn't actually do anything for the code, but it is good to tell us what kind of thing equation is going to be. So equation is going to be a string, just so we remember. Okay, so now we can actually start writing our function. And so the first thing we're going to do is we're going to initialize some variables. So we're going to do self dot left is going to be a list. Then we're going to do self dot right is equal to a list. Oh. And then we do self dot balanced is going to be equal to true. Now, why is self dot balanced equal to true? Well, what we're going to be doing during the one of the functions that's going to be inside of this class is going to be checking to see whether or not the equation is balanced, and that's why we need this variable. So self.balanced tells us whether the equation is balanced and ready to go. Next thing we're going to do is make a variable called integers. And integers is going to be a string with the number 0 all the way up to 9. And this is just a nice easy way for us to tell if something is an integer. We can just use a quick check and say, is it in this thing? Then it's an integer. Next thing we're going to do is create a split. And split is going to equal equation dot split. I don't know if you guessed it. And the equation is going to split on this string. Now, just to be clear, in this program, when we do a chemistry equation, the chemistry equation is going to look something like this. This is just a temporary little note that I'll do. So the equation is going to look something like this. So if we want H2 gas plus O2 gas equals water, this is what the equation is going to look like. We have H2 plus O2 equals H2O1, like that. So I know it's kind of a weird way to write the chemistry equation, but you can see this is H2 plus O2 equals H2O. We have to put a 1 there so it knows how many O's there are. All of the elements go inside parentheses, and you'll see why that's important later. But as you can see, once we run this split is going to be equal to a list where the left side is in one item in the list and the right side is another. So we're splitting on this part, the equals, and that's why we split like this. Okie doke. So let us continue from where we just left off. The next thing we do is we say left, like I just mentioned, is equal to split 0. The first thing in split is going to be the left side, and now we need the right, which is equal to, if you can guess it, split 1. There we go. The next thing we do is we have a dictionary called left components, and left components is going to be equal to, oh sorry, not a dictionary, my bad. We do left dot split again. We're splitting, and this time we're splitting on the space plus space because we want to actually split up the components that we're adding together. On the right side, right components is going to be equal to right dot split, and we're also splitting on the plus signs. So this will split each of the sides into the actual components of that side, the compounds. Okay, after that we can leave an extra space just to organize ourselves, and we'll do total left is equal to a dictionary. This is why I thought it was a dic before. And now total underscore right is also equal to a dictionary. Awesome. So now we are going to start writing the bulk of the program. And this is going to take a while, guys, but remember, it's important so you guys learn how to do it, so I relearn how to do it, and then so I can send it to these other chemistry channels. So let's get started. So the first thing we do is we have a big loop for component in left components. Left components. Left counts is equal to a new dictionary, like that. And for ind, I call it ind. It could be just any letter. This is the index. So for index in range, and we're going to do 0 to the length of components, like that. Oh, sorry, for the length of component. So just the component. After that, we are going to say if compound. Oh, sorry, I got that wrong again. If component, I was going to say we do not have a compound variable. If component that's at index is equal to a parenthesis like this, then what is going to happen? Well, if component and then index, so ind minus 2 is equal to the other bracket, then element is equal to component, and this is where it gets a little bit weird. Element will be equal to index minus 1. And then not only is it, actually no, it is index minus 1. So what this is pretty much saying is, this little thing here, is saying that if we find a parenthesis, and if you go 2 spots back, it's the other parenthesis, that means that the element is only a 1-letter element, like O for oxygen, or C for carbon, or F for fluorine. So this is just going to grab that one element, and that's if it's a 1-letter element, but it might not be a 1-letter element. So now we're going to say that elif component at index, and then this is going to be minus 3, I believe. Let me check. Yep. Is equal to this other parenthesis here. Then element is going to be equal to component. And now this is going to be interesting because it is a range. So here we're going to do index minus 2 to end. So what this is pretty much saying now is if it is a if the element has 2 letters in it, so like Fe for iron, then it catches it here and it makes the element equal to that symbol, Fe. So now we've done the if, we've done the elif, and here's where it gets a little weirder. This is a weird program, and I'm sure there's a way better way to write this program, but I did it the best I could, guys. So here we go, we have try, and try is going to try something, and if it doesn't work, we'll write an except later. So try if component, and now this is looking for the number part. We've already got the element in this little section here, and now we're going to look for the number. So if component, let me just check, yeah, if index plus 3 is in integers, so now we're checking to see if it's in that list. So if it's in integers, then the number equals int of, because we're turning it into an integer, component ind plus 1 all the way to ind plus 4. This is assuming that the number is 3 digits long. So this is just like an extreme situation where you're talking about some crazy hydrocarbon with like 100 carbons. You're probably not going to be using this program to balance that sort of thing, but you never know. So I just put it in there to be safe. The next thing to try is elif, the component ind plus 2 is in integers. Then the number equals, we can actually copy this whole thing so we can use it later, and then we can paste it right down here. So we can say this except going to 3 instead. So that one goes to 3, and then the last situation is we have else. If it's not 3 digits long and it's not 2 digits long, then it's probably 1 digit long. And so in that case, we do this. Let me just tab that into the correct spot. Same line as up there, except we can take out the range and just have ind plus 1, and that'll be equal to our number. Now, that is the ideal situation. Unfortunately, there might be an index error. So what we do is we say except index error, like that. And now under the index error, we try something else. Try if component index plus 2 is in the integers, then the number equals this. Now, you might recognize we've already written this. We wrote it above. Why, oh why, would we be doing it again? And the reason that we're doing it again is because, unfortunately, the way that I wrote this program, if this loop fails somehow, you need to try, if there's an index error during this, say that you put in a 2-digit number and then the program tries the first thing to check if it's 3 digits. It's going to fail because there's going to be an index error. It's not even going to pass on to these two. So what's the best thing to do? Best thing to do is write another of these loops, except we start with the second portion here. In other words, I could really honestly just take this and stick it in here. And let me just tab those into the correct spaces, like that, and just change this to an if. So that is the alternative. And then we can say that except, just like you guys probably expected, another index error. What are we gonna do? Well, you just grab this. Well, actually, let's grab this one for time's sake. Copy it here and say that, let's see, if end is in integers, then we can just get rid of this, get rid of the range. If end plus 1 is in integers, like that. Cool. So now we have done the bulk of it. The last thing we have to do now, which is kind of annoying, is we have to, so let me just check. I want to make sure I get these indents right because I've actually like printed this out and like gone, okay, so I think it's like too bad, like here. So here we are going to write a quick loop and, or sorry, no, a conditional. And we're going to say if the element is in left counts, because we're in a big loop already, so we don't have to write another loop. It can just be a conditional. So if the element is in left counts, which is that dictionary, then left counts is going to be, left counts of the element is plus equal to the number. So what this is pretty, what is going on up here? Oh, that's my bad. I almost missed that. Boop. I don't know why it's giving me a hard time. Boop. There you go. Okay, so this is saying if element is in the left count. So if you've already put the element in the dictionary, then just add the number of the element that you just counted to that dictionary on the left side. Now we say else, if it's not in left counts, then left counts element is going to be equal to the number. Now we can actually take this little thing that we just did, and we can copy it, put it there again, and except this time now we're saying if element is in total left, and then we can do that. So now if element is in, let's see, total left, then total left, and change this to total left. There we go. So what we're pretty much doing in this entire this whole loop here, oh sorry, let me just quickly add the last line so I don't forget. This last line should go outside of the loop, so here. after the loop is done. And after the loop is done, we say that self dot left dot append, and we're going to say it appends left counts, like that. Cool. So, and let me just make sure that I'm doing this in the correct way, because I want to make sure I've actually tabbed in twice and then tabbed out twice here, because this from the bottom should be tabbed 3 times. 1 tab, 2 tab, 3 tab. However, it looks like it's tabbed 4 times, so I'm actually going to tab that in. Boop. Okay, perfect. So now we've done this. This is for the left side, and I know it looks complicated as hell, and kudos to you guys if you followed along through the whole thing. What this loop is, this whole part, is it's taking the equation we just gave. It's parsing it. That's why it's so big, because it's parsing it, and it's counting the elements on either side. So it's saying, okay, how many elements are on, how many oxygens are on the left? How many hydrogens are on the left? Now we have to do the exact same thing that we just did for this, except we're going to copy it, and we're going to paste it right here. Boop. Except now we change this to right, because we're just doing the exact same thing for the right side, like that. Okay, so right counts, and now we need down here at the bottom to change this to right, to change this to right, to change this to right. This has to also be right, and this has to be right, and then down here, right and right, like that. Perfect. So now, that was a lot faster, obviously, than the other stuff we had to do. And then there's one last little thing that we have to do at the end. And the last thing we have to do at the end is we say that for key in total right, like this, if total left, like this, if total left key is not equal to total right key, and this is in the totals for the counts, right? So if the total left key is not equal to the total right key, then we have an issue because it's not balanced. So self dot balanced is going to be equal to false. Otherwise, so else, continue. And so what this is pretty much doing now is you've got this big, massive loop. And the big, massive loop, well, there's 2 massive loops and then a third little one. So this big thing up here checks the left side and creates this dictionary where it's counting all the elements on either side just to make sure that there's an equal amount. This one down here is doing the same thing for the right. This little loop at the end is just saying, okay, look, I've just put that whole equation you gave me into this list, and now let me just check if it's balanced. If it's not balanced, we changed self.balance to false. Otherwise, we just continue. And that's because in our next equation, you'll see why it's important that we set self-balance to false if it's not balanced. Because right now, if it continues without setting it to false, it assumes it's already balanced, so why would we do any extra work? So down here, we are going to write our balance function. So def balance, like this. And there we don't need any parameters, we just need self. We're going to make a little note and say that this balances the chemical equation, like that. Cool. Okay. Why is it giving me an issue? Too many blank lines. Okay, we'll take that one away. Okay, so this is our second little thing. So we have, this is our first function. It's huge. This is our init function. Now we're going to write this balance function down here, and we're going to be able to call balance on the equation object to balance it. So this is going to be the important one, guys. Well, I mean, this is equally important because you have to put it in a form that's able to work with. That's pretty much what's going on, is that this is putting the function into the equation into a way that we can work with it. Down here is going to be what works with it. So in here, we're going to start out by handling this information we just did here. So we're going to say that if self.balanced, like this, what are we going to do? We're going to say string equals a string, like a new string, and for every single dictionary, not like that, for every dictionary in self.left, we're going to say compound equals a string, like this. And not only does compound equal a string, but let me get my other paper. Now for every key in the dictionary, like that. So for every key in the dictionary, we are going to say that compound plus equals the string of dictionary key. Okay, so that's creating, that's going to create the first compound, and then after it creates the compound, we're going to say that string plus equals compound. So you can see we're making a string. For every dictionary, we're making a new compound, and then after we're done making the compound, we attach it to the string, and then what do we do? But we do string plus equals, and then we took it out earlier, space plus space, like that, right? Then we come out of this loop and we say that string equals string, except it's going to equal string, the range of the string from, the beginning to the length of string, like this. Length of string minus 3, and then we're going to add, I don't know if you guessed this one because I'm being a little complicated with this, but you're going to add that equal sign, right? So now, did I say sting again? There we go, string. So string is going to be equal to string, the range from the beginning of the string, except to 3 spots back on the string, plus the equal sign. So this is just, you're adding the equal sign, in other words. Now we can take this whole thing except for adding that plus sign. Oh, by the way, the reason that we do this instead of just adding a plus of the equal sign is because at the end of the loop we add an extra one of these. We add an extra plus, so we have to get rid of that extra plus and change it to an equal sign. We take that whole thing, copy it down. Oh, I lied. We're just taking this like that. Boop. Okay, cool. So now we change everything to right because we want to do the same thing to the right side. So we really just changed self.right, and then that's it. Except down here at the end, what you do is you say that the last thing that the string equals is, well, we can just take this same thing here, like that, except we don't need another equal sign. We change this to 2, and leave it like that. Perfect. There we go. And now we can actually say return string. So that might seem a little complicated. Well, that's just the beginning, guys. So we're what we've done here is we've said that if the equation is balanced, create the equation and print it out. Now we got to write the else, and the else is going to be long. So, oh boy, we're going to do this all in a while loop. Okay, so in the while loop, we're going to be balancing the equation. It is going to be something like you have never seen before. Let's do it. So we're going to do while not self.balanced, because this is, we assume, we just checked if it's balanced and it says it's not. So while it's not balanced, we're going to keep trying over and over again, because this is through random number generation. So the temp left is going to be equal to a list. Temp right is going to be equal to a list, like this. And now we need total left, which is going to be equal to a dictionary, and total right, which is going to be equal to a dictionary as well. Okay, so now we've started our loop. For item in self.left, right? Our first for loop, we're going to say that there's a new dict, and the new dict is going to be equal to a dictionary. I don't know if you could have guessed that, probably. And now the next thing we need to say is for key in item, because we remember that item is going to be a dictionary, so for every key in that dictionary, new dict key like this is going to be equal to item key. What we're pretty much doing here is we're taking self.balanced, or sorry, we're taking self.left and we're making a copy of self.left. And the reason we're doing that is because we're going to want to mess with it without changing the original, because we're going to have to try messing with it many times, and so we need it to stay the same so we can copy it every single time. Then we say that temp left dot append, and we say new dict like this. Awesome. It says there's a typo in new dict, so I'm just going to add an underscore like this. Oh, why is it giving me a hard time again? Come on. Oh, there we go. Perfect. Okay, so now that's fine. We can actually take this whole thing, because I don't know if you've seen a pattern here. Whatever we do for the left, we usually do for the right. So change that to right, and then at the end, change this to right, and self.right. Yeah, perfect. Now we append new dict to temp right. Okay, so now we have those loops. Now we're going to generate a set of random coefficients for each component, and we're going to see if it works. So first thing to do is that left, left coefficients. Oh, sorry, like that. Did I spell coefficients right? I hope I did. I think it might actually be two O's. Is it like this? No, that would be coefficients. No, I don't know. We'll see in a second. That's going to equal a list. In the list, we're going to have randants between 0 and 10, like this. And the randants from 0 and 10 are going to be for underscore in range. And then we're going to do the length of temp left, like that. Okay, so we've done the left coefficients. We are going to copy this whole thing, go below and change this to right, because we want right coefficients now, and we're going to do in temp right, like that. So now we're generating random coefficients to see if those coefficients balance the equation. The next thing to do is going to be to say, okay, so we've just made these coefficients. Let's try doing new counts with the left coefficients. Okay, this is when it gets a little bit annoying. So, I mean, it's already probably super annoying. Just bear with me on this one. Let's do it. Okay, so for index in range 0 to the length of left coefficients, like this. Oh, that's not where I meant to put that. Put it here. Okay, for index in range 0 to the length of left coefficients. For key in range, for key in temp left. Temp left index. Like that. Yeah, there we go. For key in temp left index, temp left index key, like that. We're getting really meta here. We're going like inside the dictionaries. It's going to times equal, okay, times equal left coefficients at index. So here we're multiplying and setting equal to whatever the amount of that element is times the left coefficients index, so the amount that there actually are. All right? So we're just making these big numbers here and testing to see if they work. Now that we've done that, in that second for loop, we're going to say if key not in total right, like that. If the key is not in, oh, sorry, I lied. This is in total left. There we go. So if key is not in total left, then total dot key, key, like that. Total left key is going to be equal to temp left index key, like that. Okie doke. And then otherwise else, then we're going to do that total left key is going to be added to and set equal to temp left, and then we're going to do index, and then we're going to do key. Just like that. Okay, cool. And now, lucky for us, we do not have to write that all over again. We can just use the magic of copy and paste and change all of this to right. So we'll go line by line. We need to change that to right coefficients. We need to change this to right, temp right. We got to change this to temp right, and then also this to right, right? And then we got to change this to right as well. And then we got to change this to right. Got to change this to right. And then we got to change this stuff down here to right as well. Right and right. What this is pretty much doing is it's resetting that dictionary to try to see if it's balanced. We're taking those new coefficients and pretty much processing them to make them into an imaginary equation, and now we're going to test if that equation is balanced. So next thing to do is to test. So self.balanced, we set it equal to true because it has to start off true to begin with, and then we test. How do we test? Well, we already tested up here, so why don't we grab it like this and bring it all the way down like that. So now we check that we're going to change this to total left like that. and we're going to say if total left key is not equal to a total right key, then self-balanced is going to be equal to false. Otherwise, it continues, which I think is exactly what we want. Otherwise, yeah, okay, perfect. So now this is when we actually produce the function, because this is going to keep this whole thing here is going to keep iterating, like it's a while loop, right? So it's going to keep spinning, spinning, spinning until it's equal. Once it's equal, we got to make a new function. So down here, we're going to make a variable called big tup. I call it big tup for tuple, and the big tup is going to be a tuple, and inside the tuple we're going to have left coefficients, and then we're going to say plus right coefficients. That is going to be our big tuple. Now in the left coefficients, okay, left coefficients is going to be equal to a list. And this is going to get a little tricky, guys. We're going to map lambda, okay? So map lambda x colon int, and now this is going to get really, really weird. X divided by reduce, okay? We're going to reduce GCD, okay? And we're going to reduce GCD and big tuple, okay? Then after these two parentheses here, we do a space and we say left coefficients, okay? So what we're doing is we're going through all those coefficients and we're like, okay, cool, we balanced it. We generated a bunch of random coefficients and we balanced it. But we want to bring it down to we want the greatest common factor, right? So we want to, or sorry, the greatest common denominator. So we want to actually take the, we want to find like the least common factor. You'll see it when we actually use it. For example, if we have something that's the ratio is 10 to 20, we can just do a ratio of 1 to 2. We're pretty much finding the least common denominator, or greatest common denominator, sorry. Okay, so now we do the same thing with the right coefficients, like that. Okay, right coefficients, we change this to right, we keep, and yeah, we change this to right as well, right, like that. Okay, awesome. So now that is done. This little part is done, and now what we can do is we can say that we make a new string down here. This is where we're creating our function, and we say string for, actually, I think, I'm not positive, but in the top of our, do you remember we had this? Let's grab this, because I'm saying for index in, no, unfortunately it's different. We can't copy it, sorry. So string is equal to a string like this, for index in range. And in the range, we're putting 0 to the length of self dot left, right? Now we're saying if left coefficients index, like that, is not equal to 1, like that. And that's, remember, not equal to is an exclamation point and an equal sign. Is not equal to 1. Then compound is equal to the string of the left coefficients index, like that. And the reason that we're doing that is because we want to make sure that if it's 1, we don't need to put a 1 there. We can just leave it without a number, because we assume if there's no number, then it's 1. So compound is equal to the left coefficients at index. Okay, cool. So now we do else compound is equal to a string, like this. Perfect. And for key in self dot left index, like that. Awesome. For key in self dot left index, compound plus equals key, and if self dot left at index, oh, this is okay, index key, then if this is not equal to 1, like that. So we checked above, now we're checking again below. For key in self.left index, compound is plus equal to the key, and then we check to see if it's equal to 1 again, and we say compound plus equals the string of, this is where it gets similar to above, this is what tricked me before, self.left, like that, self.left index, and then not 0, we need key, like that. So that shouldn't give us a problem. Yeah, awesome. And then we say else, it continues, and if it continues, then string plus equals the compound, and then string plus equals, you know it, that nice little plus sign with spaces around it, and then string is going to be equal to string, the range of length of string, oop, boop, length string, and then that's going to be -3, like that, plus our trusty equal sign, like that. Awesome. Now, what do we do? Oh, sorry, this is also back an indent. Make sure you put that back an indent. Okie doke. Now, we take this whole thing, including this, and we say, like this, we will put that down here, boop. Now we change all of these to right, like this, right, right, just making sure I don't miss any of the rights because that'll mess up the whole thing. Right, right, right. Perfect. Okay, so then at the bottom it's equaled to this -2. Get rid of the equal sign because we don't need another one at the end. And what do we do at the end of this whole massive thing? We return string. And there you have it. This is our class. We are finally finished with our class. So this is the part, remember, that initializes it, puts it in a form we can mess with, and then this down here is the part that actually balances it. So now we have to write one more thing. It's pretty quick, and the last thing we write is, oh, just making sure I'm not missing some error down here. Is there an error? Yep, I forgot to put a colon there, and I forgot to put a colon there. There we go. Okay, so now let me just get rid of this. Okay, so that is fine. Now the next thing we do is we make a Python file called main, and in main we're going to say from equation, the file we just wrote, import capital equation, because we remember classes start with a capital letter. So we add the equation, we have imported it now, And now we'll say def run balance. So this will run our program. So we'll just add a little note, and the note will say runs balancer, or runs balancing program. Okay, here we are going to start off by saying print. We are going to print some equal signs like this. We can even put some more just to be safe. And we're gonna Control C that. And yeah, we can actually leave it like this. And so now the next thing we are going to do is we're going to say we need an input. So the actual equation is going to be equal to input, right? And the input from the user is going to be, we'll just do 3 of these, like greater than signs, and then we'll say print enter chemical equation in the correct format. So that means, so first it'll print this, it'll say enter chemical equation in the correct format. Then you input the equation like here, and after that it's going to take it and it's going to say, okay, so now we need some kind of variable. We'll say user input equals an equation object made with equation. So we're taking this equation, putting it into an equation object, dot balanced. And now we say print, here we'll say balanced equation. Equals that, and now we're going to print the balanced equation like this. Actually, and before that, let's print like a couple of these. It'll just give us a little bit of, actually here, we can just do this. We'll do \n, should give us, or sorry, maybe it's /n. Yeah, that should give us a new line. So /n gives us a new line. We'll do this, and then we'll have it sleep. For that, I'm going to need to import sleep from time, import sleep. And then here we will say, finally, sleep for 5 seconds. After that, run balance. Down here, we type run balance, and now it should be working. Hey guys, I am back. Sorry about that. I just fixed up a couple errors, and let me just quickly go over what I fixed. This should not be balanced, it should be balance. Balanced will actually print whether or not it's balanced, true or false. This will actually balance it. So and just to show you, I can put some parentheses there. So that's a function, yeah. So we change that to balance with parentheses. And then in the equation file, I actually had a little bit of an error up in here. I just fixed it. It was kind of complicated to fix on video, but all of the code for this is in the description, in the video description. So what you should do is go to the video description, go to the synthetic programming GitHub, and you can actually see the corrected file, which I have right here. That's on the synthetic programming GitHub under the chemistry equation balancer. Now, just to prove that it's working, we can run it again like so. I can paste in, because I got tired of, here we go, like this. So we got H2 plus O2 equals H2O. You have to put 1 so it knows how many O's there are. You hit enter, and it says 2H2 plus O2 equals 2H2O. Okay? You can do a bunch of other equations, and on the Synthetic Programming GitHub, I've actually included a test file that has a bunch of equations. Like a lot of ones you can mess with, some ones about photosynthesis and like replacement reactions, so go check those out. That is going to conclude our chemistry balancer for today. My name is Ethan from Synthetic Programming. Thank you guys so much for watching if you made it this far. I know this is a long video and it's really complicated code, but like I said, all of the code is on the Synthetic Programming GitHub. You can find the link in the description to that. Also, check out our website at syntheticprogramming.com. We have 2 patrons now. Thank you to those 2 patrons. Thank you guys so much. And yeah, like I said, I'm Ethan with Synthetic Programming, and I'll see you guys in the next one. Peace.